This is Mr. V. Welcome to this video series on linear programming. This video is going to be on finding possible solutions using common areas. So here's the question I've got. Mohammed can afford to spend up to $2,000 on some new equipment for a sound studio. Microphones are $80 each and professional quality headphones are $120 each. He must buy at least 12 microphones. So at the end of this question, we want to be able to show all the possible combinations of microphones and headphones that we can buy. That's our aim. As always, we're going to start by identifying our variables and parameters. Remembering that variables are the things that can change and parameters are the things that don't change. So reading through my question, all of these values have something to do with money, and he's buying them, so we'll have a cost variable. And Mohammed can buy some number of microphones and some number of headphones. So the number of microphones and headphones will be our other variables. So we have number of headphones and number of microphones. The parameters attached to those will be the costs of both of those. So headphones are $120 each, while microphones are $80 each. Now we've also got some constraints. We know that Mohammed only has $2,000 to spend on headphones and microphones. So the total cost has to be less than or equal to $2,000. We also know that Mohammed needs to buy at least 12 microphones. So the number of microphones has to be larger than or equal to 12. So writing out the constraints fully, we'll make this 1, we'll make this one 2. For 1, the cost is going to be $120 times the number of headphones, let's call it H, plus 80 times the number of microphones, let's call it M. And the cost needs to be less than or equal to $2,000, so this needs to be less than $2,000. So we have $2,000, it always has to be more than the total cost. My second constraint is that the number of microphones has to be larger than or equal to 12. Now I need to rearrange this equation for this first linear inequality. So let's do that. If I head over here, number 1 star, we have 2000 is greater than or equal to 120h plus 80m. I want to make m my objective, so I'm going to get rid of 120h first by taking it away. So 2000 take 120h is greater than or equal to 80m. Now to get rid of the 80, I'm going to divide by 80 on both sides. So 2000 minus 120h divided by 80 is greater than or equal to m. 2000 divided by 80 equals 25, minus 120 divided by 80 is 1.5. And now I'm just going to rearrange that equation, or reshuffle it to make it look a bit nicer, and it will turn into m is smaller than or equal to negative 1.5, it should be h plus 25. And that's the equation I want to draw. Okay, I'm going to move this up to the side, and I've already drawn a grid here that I'm going to use. And I'm going to start by drawing the inequality we just rearranged. Now m is my subject, so I'm going to put m on the y-axis, h on the x-axis, and I'm going to use my gradient method, to draw this because it's easy. I'm going to put the intercept on first, so m is 25, that's my intercept. And for every one step across, I'm going to go down by 1.5. And if I do that twice, I will have gone across 2 steps and gone down 3. So I can do 2 steps at the same time, and it just makes it easier to draw this on my graph. So if I go across 2, 1, 2, 3, 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 and that's enough dots for me to then grab my ruler, draw that line. Just making sure it lines up correctly. There we go. Okay. Now m needs to be less than this line, so we're going to shade below the line. The second inequality we have is m has to be greater than 12. So we find m is equal to 12 on our graph, 10, 11, 12, that's over here. And this is just going to be a dead straight line, straight across. And m needs to be greater than this line, so we're going to shade above the line. Now looking at this graph, we've got one area which is covered by both of the linear inequalities. This triangle here is the only area that is both above this line and below this line. So this entire area covers my possible solutions. We can pick any combination as long as it is in this triangle. That is how you find the possible solutions given 2 or more inequalities.